Hello, my name is Gabriel Taylor. I'm a sophomore studying meteorology here at the Florida Institute of Technology. This is a presentation for my meteorology class, but I wanted to make a YouTube video for it to talk about how meteorologists can use radar images of mesoscale boundaries to better predict thunderstorms. And I'm going to use an example of a single cell thunderstorm that interacted with an outflow boundary and quickly intensified. So what is a sea breeze boundary? It's one of the mesoscale boundaries we look at. They're very common in the summer, especially in Florida, as the land and the peninsula is heated more quickly than the ocean. So the air over the land rises and the air from the ocean is drawn inwards, which creates these boundaries called sea breeze boundaries. And you can see it here along the east coast of Florida and parts of the western coast where there are no clouds. And then further inland, there are cumulus clouds and thunderstorms starting to develop. So these sea breeze boundaries, usually the atmosphere is something called conditionally unstable, which means you need a trigger in order for thunderstorms to develop. And these sea breeze boundaries act as that trigger and create thunderstorms. These thunderstorms then create their own boundaries called outflow boundaries from evaporative cooling. As the rain cools the air, it falls down to the ground and pushes outwards. And these boundaries create more areas of localized lift for more thunderstorms and can create a domino effect of more thunderstorms and thunderstorms being intensified from these boundaries. That makes these boundaries very important to forecasters, and they can be very useful for small and local scale forecasting. So our example here is from March 10th of this year during our spring break. There was a sea breeze boundary that occurred along the southeastern peninsula of Florida. It created some afternoon convection, which created an outflow boundary, which pushed northwestward towards Lake Okeechobee and collided with a prefrontal cell. It was just a single cell thunderstorm. And upon this collision, the storm quickly intensified. You can see here the outflow boundary from the storms in the southeast pushing northwestward towards Lake Okeechobee. The cell starting to grow here, remaining pretty consistent until it collides with the outflow boundary. It then intensifies and changes direction. A closer look at that same storm shows the cell moving eastward, north of Lake Okeechobee. And then upon collision of the cell, it intensifies, the precipitation rates increase, and the lightning activity increases. And on top of that, the storm changes direction towards the area that the outflow boundary was coming from. That's because these storms, they like to follow outflow boundaries because these boundaries act as sources of lift, and the thunderstorm will then propagate towards that area of lift. And sometimes that area of lift will help the storm create an updraft so strong that eventually the thunderstorm is surrounded by air that's colder than itself. That makes the storm rise even higher, like a helium balloon, and can create overshooting tops, as you can see with this storm here. This is the visible satellite. It starts off not too strong, but as it collides with the outflow boundary, it quickly intensifies and even creates its own shadow on the east side, and it's a little bit brighter on the western side. And this was during sunset, so that helps enhance that shadow effect. But the storms are still intensified enough that it can create shadows due to the storms being so tall. So how can looking at these mesoscale boundaries be useful for meteorologists? Although these boundaries may look innocent at first on radar, if it is looking like it's going to collide with a storm, you can expect quick intensification upon collision, which can create conditions such as hail, stronger wind gusts, and frequent lightning. Sometimes these collisions can be so strong or enhance the storm so much so that the storm needs to be warned because any hail from it or wind gusts from it are meeting the severe thunderstorm criteria. I hope you learned something from that, and I hope you have a good week. I'm Gabriel Taylor. See you later.